Now let us understand what is electric dipole. Electric dipole. So in this class we will try to understand what is electric dipole, and let us find out the electric field at points due to the dipole. So dipole, di means two, pole means two opposite charges, dipole, two opposite charges. Okay. So electric dipole, it's a system of two equal and opposite charges placed at a certain distance apart. That's electric dipole. That's just an arrangement only. Okay. Suppose you consider two charges which are equal in magnitude but opposite. Okay. Suppose you consider a charge plus Q placed at A and an opposite charge minus Q, suppose, placed at B. So this plus Q and minus Q are two equal but opposite charges. Alright, they are equal in magnitude but they are opposite charges. So two equal and opposite charges placed at some certain distance apart. Placed at some certain distance apart. At some certain distance apart is known as electric dipole. But the distance, here I have kept the distance maybe around 15 centimeter. But the distance between the two charges should be like very small. Suppose in nanometers maybe. In micrometers maybe. Is it okay? Oh, not microcoulomb, micrometers, can be nanometers. Like 10 to the power minus 9 meter. 10 to the power minus 6 meter, 10 to the power minus 8 meter, 10 to the power minus 7 meter, 10 to the power minus 10 meters. Are you getting me? So this arrangement is known as your electric dipole. So a system of two equal and opposite charges, okay, placed at a certain distance apart, that is known as your electric dipole. Now, so this is your positive charge placed at this point A. This is equal and opposite charge minus Q placed at point B. This is the distance between them. And you do not measure the distance from one charge to other charge. Distance measure koribi koile to ekta charge pra ekta charge pra measure no koribo. Is it okay? Distance to kinaka measure koribo. Locate the center of the dipole. Is it okay? Locate the center of the dipole. And suppose the distance of this positive charge from O is A. Distance of this negative charge from the center of the dipole is A. Equal distances of O, no? If O is the center of the dipole, no? Then this distance will be considered as 2A. On all the derivations due to the dipole, we'll be using these distances as 2A. Are you getting me? Is it alright? Yes. In some books they take L, in some books they take X. So if the distance of either of the charge from the center of the dipole is X, then the length of the dipole will be 2X. If the distance of either of the charge from the center of the dipole is L, then the distance between the two charges will be twice L, and so on. Okay? We usually take A. That's fine. Now the next one is dipole moment, electric dipole moment. Electric dipole moment. Electric dipole moment denoted by P. It's a vector quantity. Okay, it's a vector quantity. So electric dipole moment is defined as product of either charge. Either you can take this charge or this charge, any one. Product of either charge and the distance between the two charges. It is known as your electric dipole moment. Okay? So the electric dipole moment is defined as product of either charge and the distance between the two charges. that is known as your electric dipole moment. So this is what you have to keep in mind now. Okay? Are you getting me? Now what I'm going to do is I'm going to derive a relation on electric field due to this dipole on the axis of the dipole. On the axis of the dipole. Means on the same line joining the two charges. Is it okay? That is the axis of the dipole. So electric field at a point due to the dipole is it okay? On the where? On the axis of the dipole I think I should improve my handwriting because everyone will be watching the video, at least few of you. Electric field, but my handwriting is much better than this, okay? It's marker is a handwriting killer. That is why. Electric field at a point due to the dipole, but where? On the axis of the dipole, okay? Yes, so I'm going to draw the figure. So whenever we say dipole, then you have to draw two equal and opposite charges separated by a certain distance apart. Okay, distance between the two charges will be 2a. Okay, that is how you have to take. You just don't take like distance between the two charges is d. Do not take that way. All right, never take that way. So a system of two. Suppose a positive charge plus q is placed at a. Another charge minus q is placed at b. So this is your dipole. Let O be the center of the dipole. Now, distance of this A from the center of the dipole will be small a. Distance of this charge from the center of the dipole also will be small a. So the length of the dipole will be 2a. So I want to find out the electric field at this point, say P, on the axis of the dipole, means on the same line joining the two charges. So I want to find out the electric field at P. So the resultant electric field at P, I want to find it. See, there will be two electric fields acting at P. One is due to this charge plus Q. Another one is due to this charge minus Q. Is it okay? Or I can make some more arrangements. I can change this arrangement like this. Shall I place charge minus Q at A plus Q at B? This is also possible, right? Is it okay? Doesn't mean that like this should always be the positive charge. This is always be the negative charge. It doesn't mean like that. Okay, they can be anywhere. So I want to find out the electric field at this point, okay, P, on the axis of the dipole. Now there will be two electric fields acting at this point P. One is due to plus Q placed at point B. Another one is due to minus Q placed at point E. Is it okay? Now, the electric field at the point P due to this plus Q will act in this direction. Will it act in this direction? Why? Because the electric field for a positive charge is directed outwards. So EB, let's say EB means electric field at point P due to the charge plus Q placed at B. So EB will act in this direction. And the electric field at this point due to minus Q placed at A will act in this direction, right? Because the electric field at a point due to a negative charge will act inwards towards the charge. Is it okay? Yes. So the resultant electric field at P will be the algebraic sum of EA and EB. Is it okay? Algebraic sum. So the resultant electric field at P will be the algebraic sum of electric field at A, or due to A, and will be the algebraic sum of EA and EB. Are you getting me? But which one is greater? Which one is greater? EB is greater because point P is placed very close to the positive charge, right? Is it okay? So in that case, the resultant electric field at P will be given by EB minus EA. Why minus? Because the electric field are acting in opposite direction. So minus. Why EB minus EA? Because EB is greater than EA. Is it okay? Yeah. As EB is greater than EA, that is why we do this. Okay? Yeah. Are you following this? So we have to find EA, EB, subtract them, finish, resulting electric field. Okay? And we will introduce dipole moment at the last, that's all. So I'm not going to write any sentence construction here. Okay, I had that part. I'm just going to do it. See, you already know the electric field at any point due to charge Q. The electric field at any point due to this charge Q is given by what? Is given by 1 by 4 pi epsilon naught into Q upon square of the distance, R squared. Suppose this distance is R, then R square, right? So I'm going to use this concept, alright? Now, let's say that this point P is placed at a distance x from the center of the dipole. Let's say that this point P is placed at a distance x from the center of the dipole. All the measurements should be taken from the center of the dipole, okay? Then we know that electric field at point P due to plus Q at B. Now, the electric field at this point P due to plus Q at B, EB. I'm finding only the magnitude, okay? Will be given by what? 1 by 4 pi epsilon naught into Q upon this distance. Now, this distance E upon, okay, let me write PB square, PB, okay? So that's 1 by 4 pi epsilon naught into Q by, what is your PB? PB means OP minus OB. So x minus A holding square. Are you getting me? And the electric field at P due to minus Q at B, I mean at A, EA, will be given by 1 by 4 pi epsilon naught into, don't take minus Q because I'm taking only the magnitude, upon what? PA square, right? PA square, right? Distance of this point P from this charge is PA. So PA square. So that's 1 by 4 pi epsilon naught into Q by, what is your PA? X plus A. So X plus A square. So the resultant electric field at P will be given by EB minus EA. EB minus EA. I think I should get. Let's see how far I'll get. Oh my god, this can be worse. Oh yeah, it's good. So the resultant electric field at P. So at P, the resultant electric field will be EB minus EA. EB means 1 by 4 pi epsilon naught into Q by x plus x minus A. X minus A holding square minus 1 by 4 pi epsilon naught into Q by x plus A holding square, right? I think you know what is epsilon naught. There was a story behind that, no? Permittivity, but it was not permitting. So we can take Q common. Then we have 1 upon x minus A holding square minus 1 upon x plus A holding square. 1 by 4 pi epsilon naught into Q. What will be the LCM? LCM. Yeah. X minus A holding square times X plus A holding square, product of the denominators if there is no common factor, right? So X minus A square cancel, so we have here X plus A holding square minus X minus A holding square, right? So this is 1 by 4 pi epsilon naught times Q. Let us expand. A square plus 2AB plus B square minus X square plus 2XA minus A square. I'm expanding at the same time I'm multiplying by this negative. What can you say about the denominator? X minus ax plus ax square minus a square and then holding square. No? So 1 by 4 pi epsilon naught into Q. So what do we have here? I need not write a bracket anymore. It's not required. 4xa upon x square minus a square holding square. Correct? Okay. Now I'm going to introduce the dipole moment. What was dipole moment? Product of either charge times the distance between the charges, right? So if P is your electric dipole moment, then P will be given by Q times 2A, product of either charge and the distance between the charges. In that case, your E will become 1 by 4 pi epsilon naught. I'm going to rearrange this a bit. 1 by 4 pi epsilon naught now. 2 times A, Q, and then X. There should be another 2 men. 4. Okay, first I'm going to write 4 means 2. Okay, 2 times 2, I'll write 2 afterwards, and then A times Q, no? Then we have 2x left with us. And then x square minus a square, the holding square. So, product of either charge and the distance between the charges, Q times 2A will be your P. 2x upon x square minus a square holding square. So that's 1 by 4 pi epsilon naught into 2px upon x square minus a square holding square. Finish. Okay. There is some special case. Special case. See, we know that the length of the dipole is very small, nanometer. But this point P, it can be at some centimeters apart, at some millimeters apart from the dipole, right? In that case, X will be very, very large as compared to A, right? A is in nanometer. This distance of P from the dipole can be in centimeter or maybe millimeter, right? So, special case, if A is very, very, very small as compared to X, then in that case, the value of A square can be neglected as compared to X square. A square So in that case, your E will become 1 by 4 pi epsilon naught into 2px upon A square will be 0. So x square holding square x to the power 4. 1x from the numerator and 1x from the denominator gets cancelled out. So we have 1 by 4 pi epsilon naught into 2p upon x cubed. Is it alright? So that's the electric field at point due to the dipole on the axis of the dipole.